Approaching Saturn, the sixth planet from the Sun and the second largest in our solar system, is a journey unlike any other. Its majestic rings shine like a cosmic jewel box, swirling with icy particles and fragments of distant moons. But what would actually happen if you decided to take the ultimate plunge, jumping into Saturn itself? Imagine standing before the planet, an enormous golden sphere banded with shades of yellow, orange, and brown. Saturn is beautiful from a distance, but up close, its allure gives way to an ominous reality. Saturn is a gas giant, which means it doesn't have a solid surface like Earth. There would be no ground to land on, no firm resistance under your feet. Instead, you're gazing into an abyss of swirling clouds and unimaginable pressures. As you leap from the safety of your spacecraft and begin your descent, the first thing you encounter is Saturn's upper atmosphere. This layer is composed mostly of molecular hydrogen, with traces of helium and other gases. The sky around you is a pastel yellow, tinged with faint bands of color. At the edge of Saturn's atmosphere, gravity would tug you downward at over 10 times the force of gravity on Earth. You'd accelerate quickly, and unless you had serious protection, you'd begin to feel the crushing weight almost immediately. With no ground to hit, you just keep falling, passing through layers of gradually denser gas. The temperature rises as you go deeper. At first, the extreme cold, well below -200 degrees Celsius, bites at you, freezing any exposed skin in moments. But that doesn't last long. The further in you drop, the temperature climbs steadily, soon becoming hotter than the surface of Venus, the hottest planet in our solar system. While falling, you look around and see nothing but endless clouds, ammonia and water ice crystals at the upper layers, blending into clouds of ammonium hydrosulfide as you go lower. Lightning storms, larger and more fierce than any on Earth, flash around you. The violent weather of Saturn is legendary. Winds can reach over some 800 kilometers per hour, faster than the strongest tornadoes on Earth. The increasing pressure is relentless. Your body would first feel pain as the gases become thick, then the pressure would become unbearable, like thousands of atmospheres pressing on every square centimeter of your skin. Human bodies aren't built for these conditions. Without advanced protection, you'd be crushed long before reaching the deeper layers. Even with a futuristic pressure suit, survival would be virtually impossible. As you're pulled deeper still, the atmosphere thickens until it becomes more like a liquid than a gas. Yet it never becomes anything you could stand on. There are no continents, no islands, just a churning mass of gas and liquid. At this depth, sunlight doesn't penetrate. Darkness envelops you, broken only by the occasional flicker of lightning from distant storms. The hydrogen here is so dense, it starts behaving in bizarre ways, something scientists call metallic hydrogen, predicted to exist deep within gas giants. In this state, hydrogen acts like a metal, conducting electricity and fueling the planet's powerful magnetic field. Falling further, the temperatures soar to tens of thousands of degrees. The pressure reaches millions of times that of Earth's surface, crushing anything with the force usually found in the depths of stars. Your body, and even the hardest materials humans have ever created, would be ripped apart at the atomic level. What of Saturn's spectacular rings, so iconic from a distance? If you glanced back on your plunge, Saturn's rings would still appear wide and brilliant, stretching across the horizon like an endless highway. But you'd never actually touch them. Saturn's rings exist far above its thick atmosphere. In fact, if you started from the rings, you'd first need to fall through thousands of kilometers of empty space before even brushing Saturn's upper clouds. Some might wonder, is there any conceivable way to survive such a journey? The truth is, no spacecraft or suit on Earth is currently capable of withstanding the extremes inside Saturn. The environment is simply too hostile. The crushing pressure, searing heat, and chaotic storms would destroy anything sent into the planet's depths. Even robotic probes sent into Jupiter, Saturn's larger cousin, have survived only moments after entering the atmosphere before being crushed and silenced by the immense forces within. All the while, Saturn's magnetic field, a gigantic bubble of invisible force, creates dazzling auroras and traps high-energy particles like a cosmic shield. Any electronics on board your descent would be bombarded by radiation, quickly frying delicate circuits and washing away life signs of your presence. Still, the journey isn't pointless. By imagining this descent, scientists gain crucial insights into the formation and evolution of gas giants. Saturn is composed mostly of hydrogen and helium, the same elements that formed our Sun. Deep inside, under conditions we can scarcely replicate or observe directly, Saturn's core may consist of heavier elements, a mysterious aggregation of rocks, ices, and metals, cloaked in exotic ices, and possibly surrounded by layers of metallic hydrogen. But no one knows for sure. The core is hidden beneath tens of thousands of kilometers of opaque clouds and crushing depth. If you were somehow able to survive the long journey down, you would eventually approach this core, a place where science blurs into speculation. Here, at the planet's heart, temperatures may be hotter than the surface of the sun, and pressures would dwarf anything found elsewhere in the solar system. It's a realm humans can barely imagine, a hellscape of elemental chaos. And all the while, Saturn rotates with breathtaking speed, spinning once every 10.5 hours. This rapid rotation flattens the planet at its poles and stretches it at the equator, generating powerful jet streams and giant storms, including the mysterious hexagonal vortex at its north pole, a geological oddity still puzzling scientists today. As you tumble toward the center, time and perception stretch. The vastness of the planet, the depth of its clouds, the violence and tumult of its atmosphere, all combine into an overwhelming experience. There is no light, no air, no sound as you fall ever deeper. The only company in this isolated abyss would be theoretical, the countless atoms and molecules of Saturn's shifting elements, and the ghostly whispers of space probes like Cassini and Voyager, machines sent to glimpse Saturn from afar. Looking up, you'd see the layers you've already passed through, a history written in clouds and elements, stretching up toward the dimly lit skies. Above that, the void of space, the distant twinkle of stars, and the blue dot of Earth, all impossibly far away. Perhaps the most humbling truth of this journey is that Saturn's atmosphere doesn't end or change as neatly as a solid surface's boundary might. Instead, as you descend, the gas thickens gradually, then transitions to exotic liquids under pressure, and then to a hypothesized core. There is no clear moment when you can say you have entered Saturn, just a relentless deepening into uncharted territory. Why then do scientists devote so much time to studying Saturn, its rings, and its hidden depths? Because Saturn is a time capsule, preserving clues about the early days of the solar system. Its rings are likely remnants of shattered moons or captured comets. Its strange magnetic field and bizarre storms tell stories about forces still at work after billions of years. Its exotic core could reveal secrets about how planets, and maybe life itself, are created. The rings themselves, so alluring from above, would seem out of reach as you plummet below. Up close, the particles are mostly bits of ice, ranging from tiny grains to boulders the size of mountains. Saturn's gravity carefully shepherds these icy fragments, held in delicate balance by the planet's many moons. From within the clouds, however, you can only imagine their beauty, a silent ballet playing out far overhead. Storms on Saturn dwarf anything on Earth. The famed Great White Spot, a planet-encircling storm, appearing roughly every 30 Earth years, rages with electrical fury and hurricane-force winds. Even if you navigated to avoid such a tempest, Saturn's atmosphere is never truly calm. Convective towers, massive upwellings of heat, drive relentless weather, endlessly reshaping the surface you fall through. Eventually, no matter your path, the only certainty is that you would never return. Survival is scientifically implausible. Communication back to the surface would quickly fail, as pressures crush your gear, electronics melt, and radio waves become smothered by dense, metallic hydrogen. Yet there is a strange beauty in this hypothetical fall. Saturn, for all its danger, stands as a testament to the wonders of our universe, a place so unlike Earth that it seems almost otherworldly. The tale of falling into Saturn reminds us of the limits of our technology and the boundless reach of our curiosity. Each probe, each mission, is a first step toward understanding not only Saturn, but the very nature of planetary formation, solar systems, and perhaps the conditions needed for life elsewhere. In the end, the story of jumping into Saturn is not one of survival, but of awe and respect for forces far larger and stranger than ourselves. It's a reminder that the universe is full of mysteries waiting to be explored, each more extraordinary and challenging than the last. While the surface remains forever out of reach, Saturn still calls to us, a distant titan, ensconced in clouds and rings, forever tempting future explorers to reveal its secrets.